Hello, I'm Sandesh Patil from CSE A5. So today I'm going to discussing about one topic which you have in differential equation, that is the equation reducible to linear form, and equation of a type f dash of y dy by dx plus f of y p equal to q, and q is the function of x, that is the independent term here. So either we have if f dash of x dx by dy plus f of x into p q, and here but q is independent variable is y, so q is a function of y. If on the right side the q is attached to or multiplied to the term which is independent variable y, so we have to divide here. Same here also, if the term is including x in the right side, we have to divide this. And the second one is here dy by dx, the only term which should be coefficient of the dy by dx is only the dependent term variable. So if here we have the f of x term, so then we have to divide f of x. Let's see one example. If I have the equation like these, of y p equal to q, which is some function of x into y. So here we don't want y term here because the independent term is x and the only right side is variable of x, so we have to divide y here. And here the dy by dx, the dependent term is y, so the coefficient of dy by dx should be a y variable function, so here we don't want x, so then we have to divide fx into y on both sides. So we will get same function as we see here. So after this we have to put these f of y equal to v or t as you wish. So after putting f of y equal to v, f dash of y dy by dx is equal to dv by dx, hence we can replace these full term with dv by dx, then dv by dx plus vp equal to q. So here it is converted in the simplest linear equation, that is the linear equation in v variable. So we can solve the linear equation as we have studied in 12th standard, like integrating factor is equal to e raised to power p dx, and we have the solution v into integrating factor into q into e. What is our integrating factor? It is dx plus c. And after this we have one question, so let's take into the question. Here we have the question dy by dx plus x sin 2y equal to x cube cos square y. Here we can see the independent variable is x, so the right hand side it should be the function of x. So here we don't want this cos square y term in right side, so our first step is divide cos square y on both sides. So our equation becomes 1 by cos square y dy by dx plus x sin 2y divided by cos square y, and here will remain x cube. Further we can reduce this in simplest form, this x square y dy by dx plus x, here we sin 2y, we can write 2 sin y cos y divided by cos square y equal to x cube, and our final equation becomes sec square y dy by dx plus 2x tan y equal to x cubed. So here the simplest equation we have. So here we have to put this tan y equal to v because we have the derivative on the t side. So put tan y equal to v, so our derivative will give us sec square y dy by dx equal to dv by dx. So our equation becomes, instead of this sec square y dy by dx, we can write dv by dx plus 2xv equal to x cube. So here we can see, here this is the linear differential equation in v variable, and here the p is 2x and q is x cube. So p equal to 2x, q equal to x cube. So we know about the integrating factor equal to e to the power integration of p dx equal to e to the power integration of 2x dx. So our integrating factor will be e raised to x square. So we all know about the solution of differential equation is v into integrating factor equal to integration of q into integrating factor into dx plus c. So let's put the values. E to the power x square, q that is x cube, integrating factor e raised to x square dx plus c. So here we have to put one substitution here. So e raised to x square is equal to, we have to remove one x from here, that is x square e raised to x square dx plus c. If you can see, the x, when we put x square equal to t, the derivative becomes here. So let's put x square equal to t, and we get derivative 2x dx equal to dt, that is x dx equal to dt by 2. So let's put these values. V equal to e raised to x square equal to t e raised to t dt by 2 plus c. So here we can integrate these by parts. So simple by parts rule we have to apply here. E raised to x square, so here is first term is algebraic, so we can directly the generalized by part form we can use. So that is t integration of e raised to t minus differentiation of dt with respect to t into e raised to t dt. So after this, our solution is t e raised to t minus e raised to t plus c. So our equation become e raised to x square. Solution is e raised to x square half t e raised to t minus half e raised to t. So here we have two substitution, that is one of v and one of it. So let them introduce here. Tan y e raised to x square equal to half x square e raised to x square minus half e raised to x square. So here this is our final solution here. So thank you for this.